All right, let's head back to kindergarten for a second and think about how we add numbers together. Um, so right here we've got 7 plus 5. So these are both two-digit numbers, right? And so in this case, the digits are both in the ones place, right? So this is really 7 times 1 and 5 times 1 is the value of this number. Um, and so if we want to add them together, we know that this is 12, right? This is 12. Um, and we know that what really happens here is we add them, we have a 2 here, and then we carry a 1, right? This carry, remember that term? Most of you probably do that subconsciously, don't even really think about it anymore, but right, we have this carry out, and then we add that to, technically there's a 0 here and a 0 here, and that drops down to be 12. So, kind of, if we think of just for one digit addition, we have a sum and we have a carry, right? So we have the sum and the carry, and we know that our carry is never going to be more than 1 for a single digit system. If we're adding two numbers, right? If we're adding 3, that's a little different. But normally we always do 2 at a time. So now let's think of this in binary. So if we have binary, let's just look at 1 bit. And let's look at adding the biggest 1-bit numbers we can, which is 1 and a 1. So now I'm gonna put down here. I'm gonna put base 10 just so we know what we're dealing with, and this is base 2. This is just saying our base. So if we add 1 to 1, that's still, even though this is base 2, it still acts the same, where we know that it's 2. But we cannot show 2 in a single binary digit, right? We have to have a 2-digit number, right? We know that 2 in binary is 1, 0. So what that means is our sum turns out to be 0 here, and our carry turns out to be 1. And the same thing, we take this 1 and add it to these zeros, and we end up with 1, 0. We know that this is a decimal value of 2, or a base 10 value of 2. So let's look at another case here. If we have 1 and a 0, these are base 2. So 1 plus a 0, well, that's just a 1. So what that means, even though we don't show it, is we have a sum of 1, but we also have a carry. And for this case, the carry is just 0, right? It kind of indicates that there is no carry. But we added 1 to 0 and we got a 1 out. And then, of course, there's the even kind of more trivial example, which is 0 plus 0. That means we get a sum of 0. Sorry, I should put my plus signs on here. A sum of 0, and we get a carry of 0 as well. So that's how we add single bit numbers. Let's look at our example for decimal now, where we add 2-digit numbers. So now we're going to say we've got, we'll just say we've got 27 and 18. So we're adding these guys together. And so we know that 8 plus 7 is a 15, or it's a 5 with a carry of 1. So we've got 5 here, and we're carrying a 1. So now that means if we kind of cut this up in a digit by digit fashion, we're done with this digit. We've done everything that we can with it. We calculated our sum, and we generated our carry. Now we go over to the next digit, and we add 2 to 1, which is 3, and we also add in our carry. So we're at 4. So we got a 4 for this digit, and we also have a carry out of 0 for this case. So really we could add that 0 on, and we've got that leading 0. So that's how we do it in base 10. Let's do this guy here in binary. So 7 in binary, I'm going to do it as an 8-bit number. So 7 in binary is 0, 1, 1, 1. So that means I've got 4 plus 2 plus 1. And now let's do our 5 here. So 5 is a 4 and a 1, right? 4 and a 1. This is our 4's place, this is our 1's place, 2's place, and 8's place. Let's add these guys together. And we're going to just use the same process where we're going to go bit by bit, or digit by digit, right? So I might get a little cluttered. I'm not going to put those lines in there, but get the idea that these are divided there. So a 1 plus a 1, we said, is a 0 with a carry of 1. So I'm going to put my carry there. And now we're done with this digit. Now I've got a 1 plus a 0 plus a 1, which is a 0 with a carry of 1. Now, this is a little bit different here. We've got 3 1s added together. 3 1s added together, which is 3 in binary, which is 1, 1 in binary. I guess I should say 1, 1 in binary. So that means that we've got a sum of 1 and a carry of 1. Sum of 1 and a carry of 1. So that means sum of 1 and a carry of 1. So that's the end of that digit. And lastly, we've got 1 plus a bunch of zeros, which is just 1. So finally, our value in binary, right, this is all base 2, is 1, 1, 0, 0, which turns out to be 8 plus 4, and that's 12. So this is how we do basic binary addition. It's the same exact concept of decimal or base 10 addition. We're just really paying attention to our carries and remembering that we've only got 2 digits for binary. And something that I did kind of omit, but a good idea is to always plan or assume that we've got a carry coming in to this least significant bit as well. So that way our procedure is the same for each digit. In this case, it just happens to always be a carry in of 0, right?